So from our investigation, hopefully we got that the portion underneath the radical in the quadratic formula is called the discriminant. And that discriminant is a calculation specifically described by exactly what we see underneath the radical in the quadratic formula. And so what does this do? The discriminant doesn't tell us the answers, but what it does tell us is the number and types of solutions. So when we saw that the discriminant was less than 0, that meant we had 0 or none for number of solutions. And the type that was telling us there are no real solutions. And you guys are going to see in our next notes that we're going to learn something called complex numbers. And when there's no real solutions in this scenario, there is a way for us to express the answers as part of this thing called the complex number system. When the discriminant is equal to 0, there is one solution, so it is real. It is also rational. The irrational values would have to be never-ending, non-repeating decimals, and we're only going to get something like that when we have that radical expression left in our answer. When 0's underneath the radical completely simplifies. So then we had when we got a positive value, and we saw two solutions, and those two solutions are real, but they could fall into two different categories. They could be rational, or they could be irrational. And the difference here again was if that radical simplified. So if you can completely simplify the radical out of your expression, that's when you would have two rational answers. For that to happen, that means the number underneath the radical would have had to have been a perfect square to completely simplify with no radical portion left in the value. If it's irrational, that means it was not that situation, so it was not a perfect square. And then we would continue from there. So the two ways that we're going to use this information from the discriminant is one kind of applicable way. Why would we want to just know this and not know the exact solutions? And then one that's a more direct question. So mathematically, we might just ask you the number and types of solutions of a quadratic. So that's like what you see here in example 17. And in that case, we would set up the equation like you would for quadratic formula. So that means we want to bring all of the terms to one side of the equation and set equal to 0. Otherwise, you don't really know what A and B and C are. They're always referring to this standard form, and we need to have that complete setup. So now we can see the values, and if we were going to calculate the discriminant, and again, I know to calculate that because they specifically asked me about number and type of solutions rather than exact solutions. And so I'm going to plug in the values accordingly here. So 14 squared is 196, and 4 times 49 ends up being 196 for a discriminant value of 0. So I know that when that's the discriminant, that means I'm going to have one solution, and that the solution is going to be real and rational. So I have one real rational solution. The second type of question where the discriminant could be applicable is a question where maybe you don't care specifically for exactly what the result is. You just want to know if there is a result. So here's a word problem. It says a rocket is launched with this general initial velocity of 150 feet per second, and they give us a function or an equation that describes the rocket's travel. And they say h is the height in feet, t is the time in seconds. Will the rocket reach a height of 300 feet? So 300 is a height, so they're really asking about this equation, but they're not asking when will it. They're asking will it at all. So they don't necessarily care at what time. They just want to know if it's going to go up 300 feet high. So I don't need to know what the solutions are. I just need to know if solutions exist. And so that's where the discriminant would come in handy. And so I'm going to set this up like we would so that we can see it in standard form and see our A, B, and C values to use this tool. And so again here, if I'm doing a B squared minus 4AC calculation, that's 150 squared minus 4 times negative 16 times negative 300. Now, 4 times 16 is 64, and 64 times 3, 192. So this would be a negative 19,200. And then 15 times 15 is 225. You can use a calculator there. So 22,500. When you subtract these, I know that I'll get a positive number. That's enough information without even knowing what that number is to answer this question. A positive number in the discriminant meant there were 2 solutions to this problem. So this means, yes, it will hit 300. It will actually hit 300 feet on the way up and on the way down. That's probably why there's 2 solutions. So yes, okay. And then when it says explain your answer, I would want to explain that because of the discriminant value, that there are 2 solutions, meaning it will reach that height twice, okay? So I would say the discriminant is positive. There are 2 solutions, which means the rocket will be at 300 feet twice. Okay. And so that describes what's happening there.